So the two triangles below are congruent such that triangle MWY is congruent to triangle JTQ. Make a sketch of the triangles on your paper and then label all three sides and all three angles. And it does just say label them, but I'm going to take it to mean that they want us to compute all three sides and all three angles. Note that the triangles are not drawn to scale. Obviously, if two triangles are congruent, they have to be both the same shape, right? But then congruency also forces them to be the same size, so same shape and same size. So I'm going to just kind of enlarge this a little bit, and actually I've already, should just be able to paste it. Yeah, here's a nice image. So what I've done is I've taken the triangle JTQ and I've rotated it and actually flipped it so that it matches up with the other one. And then we're just going to use a little bit of inductive reasoning to fill in some things here. So I know that the three angles in a triangle have to add up to 180 degrees, and I also know that corresponding angles in triangles have to be congruent. So because of that, I can right off the bat just claim that this has to be a 75-degree angle. 75 degrees, and that's because angle M is a 75-degree angle. So we've got those two. Now, if I take 180, take away the 90-degree angles, because these are each 90-degree angles, and then subtract 75, I've got that I need a 15-degree angle at Y. So these are both 15-degree angles. Oops. And again, we're just using it's called the triangle angle sum theorem. The three angles in any triangle have to add up to 180 degrees. So we've got that. The other thing that has to be true is since they're congruent to each other, and in fact, notice the congruency. They said triangle MWY, so triangle MWY has to be congruent to triangle JTQ, J to T to Q. So the way that we're going about this, right, the M goes with the J. You can see those are in the first spots there. The W's go with a T. W goes with a T. And then the Y is going with the Q. The Y is going with Q. So all those parts are lining up perfectly. And since the triangles are congruent, their parts have to be congruent. So I know that this has to be 32 units long. This has to be 10 units long. And because they're right triangles, we can calculate this side. For convenience, I'm going to just call it X. And it's going to be the same in both triangles. So I'll just find it in triangle MWY. But I know that in any right triangle, if I take one of the legs, square it, then I add to it the other leg squared, I have to get the hypotenuse squared. So I know 10 squared is 100. So 100 plus x squared is equal to 32 squared, which is 1024. And I'm going to subtract 100 from both sides, so that gives me that x squared is equal to, I believe it's 924. And I don't think that's a perfect square root. If I take the square root of both sides, again, because this is a geometric setting, there's two solutions to that equation, both the positive and negative. We're just looking at the principal root here. And the square root of 924 is, yeah, about 30.1. And so x is about 30.1. And probably in this course, I should be rounding that to just 30 because all of my input values are rounded to the nearest whole side. So I'll say that x is about 30. So we'll go ahead and label this final side is, and I'm reluctant to just put 30, so I'll put, hey, this one's approximately 30 because it's not exactly 30. In fact, if you look at this calculator display, this is still just an approximation, but it's 30.397368, etc. So that looks like everything. Those are the two congruent triangles, and those are all their parts labeled with their correct measurements, etc. weird that I did round that to 30.1 though, because when I look at it, it's 30.39, so I should round it to 30.4. But again, in this textbook, if your input values are, if your values going into it are measured in whole units, I think that they prefer for us to just write it as a whole unit. So I'm still going to say it's about 30. A little bit more accurate approximation though would be 30.4.